what do I think is guaranteed to come up in Physics Paper 2? Well, there's nothing that's guaranteed, but if you learn the content that's come up previously well enough, then you'll be in a really, really good position for your Paper 2 on Friday. So we're going to have a look today at what regularly comes up, in particular 6-mark questions and those 3, 4, even 5-mark questions that are based on written answers, so extended writing. So we're going to have a look at questions, what topics they're from, and the ideal or perfect answer that comes from learning the mark scheme. So try and memorize as much of it as you possibly can, because I guarantee at least some of these will come up for your Paper 2. So I've looked at all the past papers since 2018, and the most important thing in Paper 2 is the required practicals. Okay, so if you haven't revised those yet, please look at my playlist about them. We're not going to cover them in today's video. Here are the topics we are going to cover. We're going to look at stars, star life cycles. We're going to look at terminal velocity, conservation of momentum, stopping distance, waves, and in particular refraction, and also motors and generators. Now, I've put a little asterisk next to the ones that are separate physics only. So if you don't do separate physics, if you do combined science, you can ignore those questions. Okay, and I'll put a reminder up on the screen as we go. Right, now first of all, just a reminder from AQA themselves, it is absolutely fine to use bullet points in any extended writing answer question, even if it's only 3 marks. If it helps you organize your answer, makes it easier to mark. Okay, I've spoken to examiners who say it is easier to mark if it's bullet points, so they actually prefer it. Make sure you read the question, underline things that are important like command words. I would do a brief plan of your answer, especially if it's a 6-marker, and we're going to do that today as we go through each question. So let's dive in. So the first question, and it has come up as a 6-marker a couple of times in recent years for separate science, is star life cycles. So for this one here, it's 6 marks. It says a star goes through a life cycle, and simply describe the life cycle of a star like the sun. So here's the content you need to know to be able to answer this question. You should be familiar with a flow chart like this, which shows what a star does as it is born from a cloud of dust and gas, goes to the main sequence, and then eventually it can either go through 2 pathways. Now, we're only going to talk about stars the same size as the sun today, so we're going to ignore the stuff on the right. If you do mention any of these things on the right that refer to stars bigger than the sun, you will lose marks. So what does the mark scheme look like for this question? So we talk about, first of all, it's the whole life cycle it's talking about. So we start from the beginning. Gas and dust pulled together by gravity. You could say it's a nebula. That might be a bit of extra detail. Then what happens next? Well, nuclear fusion begins. That's what defines the star. And in nuclear fusion, we have hydrogen converted to helium, so the forces are stable. Next stage, we're going on to the kind of left-hand branch of this diagram down here. We have the star expanding and cooling and becoming a red giant. Then, at the end of its life, it becomes a white dwarf. The clues in the name there is a dwarf, so it shrinks, its temperature rises, and glows brighter to become a white dwarf. Now, this question only mentions to describe the life cycle, so actually, you don't need to do loads and loads of detail for explaining. However, it's good information to know anyway, so if you're going to put a bit extra detail in, if it asks you to explain any of these stages, you could talk about fusion being hydrogen to helium, you could talk about what the forces are, so gravity pulling inwards, and pressure due to nuclear fusion pushing outwards. You could talk about fusion stopping when it becomes hydrogen fusion stopping when it becomes a red giant. You could talk about all fusion stopping when it becomes a white dwarf, etc. But please learn star life cycles. Here's another one. This one we've got is about a star that's more massive than the sun. So if it's more massive than the sun, this time we are going to talk about the right-hand side of the diagram. So we're not talking about the black dwarf and white dwarf stage. We're talking about the red giant supernova stage. Okay, and in this question it also says to talk about new elements and how they are formed. So let's have a look at the mark scheme for this one. Now this is a slightly more recent question. So we get marks in this question just for describing how each stage goes to the next stage, but we do need to talk about elements because the question talks about new elements each time. So first of all, we're going to talk about the gas and dust being pulled together by gravity, as last time, then increasing temperature. This one mentions the protostar, a good thing to talk about as well, even though the last question didn't. But here's the bit you might miss, which is the new elements, which is that hydrogen fuse or undergo fusion to form helium. Then the star's main sequence. Now after the main sequence, hydrogen runs out. Then we've got helium nuclei fusing to make heavier elements. And this happens all the way up to iron. So elements all the way up to iron are formed in the main sequence stars. Now on the right hand side, the next stage is a red supergiant. Okay, so it expands to become a red supergiant. Now what elements are formed there? Well, they only get formed when a supernova occurs. So the red supergiant will basically, when its fusion stops altogether, it will shrink and then explode in a supernova, and that's where we get the heavier elements. So this could come up as a separate question. How do you get heavier elements in the universe? Well, it's all to do with in a supernova, those elements that are heavier than iron that get made and they get distributed throughout the universe, and then we have those last two stages, either a neutron star or a black hole gets left behind. So if you don't mention those bits in red, if a question asks about new elements, you're probably limiting yourself to, I don't know, half marks, potentially 3-4 marks at absolute tops, because you haven't talked about the mention of new elements. Okay, so that's stars. So definitely learn that properly as a 6-mark answer. Try and memorize as much of it as you can. Right, next question, we're going to talk about forces and motion for the next couple of questions. We're going to talk about terminal velocity first, okay? So this question asks about a hailstone, we haven't got the context, but it's a hailstone stops accelerating, reaches terminal velocity. Why does it reach it, okay? So the information we need to know about this is what forces are acting, and therefore what is terminal velocity. So initially, and this isn't a hailstone, this is a baseball, the velocity going to increase because the force on the baseball is only its weight, or the force exerted use of gravity. Now, as it increases in speed, it says as the velocity increases, air resistance increases. So you have another force acting upwards in the opposite direction. Now, over time, those things are going to balance. So you'll have the air resistance, or the drag, equals the weight of the hailstone, or the baseball in this case. Okay, so make sure you know how to describe those two things. Now, when that happens, then it's terminal velocity because the resultant force is 0. Okay, now you could say the forces are balanced here. That would be fine, but I would definitely just make sure mention the resultant force, because it's often the one mentioned on mark schemes. It'll be the first thing your examiners are looking for. So that is a word perfect answer for terminal velocity. Okay, you could say, like I said, they're in equilibrium or balanced. Now, here's a slightly different question, which is a 6-marker, which is a similar kind of deal, but it doesn't tell you about terminal velocity. So in this question, this time you haven't got an object falling, you've got a cyclist traveling along. So it could be a cyclist, it could be a car, anything like that, really. And it says to describe how and explain, in terms of the two forces acting on the cyclist, why the velocity of the cyclist changes in the bit between x and y, and then y to z. Now, if you learn this graph well enough, you'll know that basically between y and z, this is terminal velocity. So we are going to talk about terminal velocity, but a bit more detail because we've got a graph involved as well. So for each part of the graph, we're going to try and mention what happens and explain it at those two stages. So first stage is x and y. The velocity, hopefully it's obvious, is increasing. However, the increase isn't constant. It increases significantly at first, but then the rate of increase slows down. So we could say something like this. So the explanation is that the force going forwards, A, has to be greater than B. So the cyclist is accelerating and velocity increases. However, as they move along, force B is increasing, and that's air resistance. So therefore, again, this word resultant force, the resultant force decreases. So therefore, they're accelerating, but at a smaller value, or the velocity isn't increasing as much. Note they are not slowing down. Next stage is y to z. Well, that's a point where the velocity becomes constant. So then you say air resistance increases, so the acceleration decreases to 0, and the two forces are equal. So the resultant force is equal, and then they are traveling at a constant or a terminal velocity. Okay, so with that context, with that question, there's a bit more context in it for a 6-mark, but it's terminal velocity again. Now, before we move on to the next question, just to note, you can get lots of questions about terminal velocity, like this one, that don't mention terminal velocity. So try and look out for it. If they talk about constant speed or anything like that, it is going to be about terminal velocity. Right, next question we're going to talk about. This is higher tier only, but it comes up on the combined science paper. This topic is about momentum, or conservation of momentum. So in this question, it talks about a skateboarder showing a person jumping off to the right, and it says the skateboard is stationary at the moment the skateboarder jumps. The skateboarder moves backwards as the skateboarder jumps forward. Explain this using the idea of momentum. So this question is all about conservation of momentum. Okay, if there's ever an explain question with momentum, it's almost always going to be about conservation of momentum. So we're going to mention that first of all. So conservation of momentum states that the momentum before equals the momentum after. Now, how does that apply here? Well, as the person or the boy moves to the right, they're going to have a momentum. But we have to talk about what the momentum is before we go about answering that. So the momentum before, because it says they're stationary, the momentum before is 0. So before the momentum of the skateboarder and the skateboard is 0. That's not really explained it yet, but you get 2 out of 3 marks just for stating what the momentum is, which is quite nice for this question. Next, we talk about the momentum of the boy goes to the right, so therefore there has to be a momentum going to the left, or the skateboarder goes forwards, so the skateboard must have an equal momentum going backwards. Okay, this could apply to a lot of different contexts, like a gun recoil, someone stepping off a boat, something like that. Okay, and I've put this one in here as well. This is what you're not allowed marks for. It says answers only in terms of forces are insufficient. If it asked about forces, you can mention forces, but if it asked about momentum, you've got to mention momentum. So I would try and memorize this as much as you can, but definitely remember the conservation of momentum because you get a mark for that straight away. Okay, this question is also about momentum, but it's a bit different because this time we've got bowling balls, we haven't got anything stationary. So it says the diagram shows a bowling ball hitting a pin, and it says explain why the bowling ball slows down when it hits the pin, use ideas about momentum. So we get a mark here, first mark, conservation of momentum, same as before, get your first mark in straight away. So you say momentum is conserved, you say momentum before equals momentum afterwards, which is very nice, 1 out of 3 for this question. Now, as the bowling ball hits the pin, now if you can picture it in your mind, you should be able to find out, well, why does the bowling ball slow down? Well, the pin actually speeds up. It's stationary initially, and then essentially the momentum of the pin is going to increase because it's going to fly off in this direction. If the momentum of the pin increases, well, if it's conserved, that means it has to decrease somewhere else. So the idea is, as the pin's velocity increases, its momentum increases, but the bowling ball must decrease because it's going to slow down. Even if not by much, it will slow down. So that explains why the ball slows down. It's all about the pin increasing, therefore the bowling ball has to decrease. Okay, next question we'll talk about, this is about kind of motion as well, but not momentum. This is about stopping distance, which I know a lot of you might think is an easy question to answer. However, it's come up a couple of times as a 2 or 3 marker. This question says, a driver of a car is distracted. Why will the distraction increase the stopping distance? Now, this is all about not looking at what the distance is, but trying to link the idea of reaction time to stopping distance. And it's an explain question. So what we mentioned first of all, well, stopping distance, we should know, is made up of 2 things, and you get a mark for quoting it. Stopping distance includes thinking plus braking distance. So write down something you know already, get your 1 out of 3 marks out of the way. Now, if someone's distracted, there's going to be an additional time before the driver applies the brakes, or they have a longer reaction time. But this question doesn't tell you how time links to stopping distance. So therefore, you have to link those 2 things together. So you say a longer reaction time means the thinking distance will increase. So a question like this is simpler than you might think, but make sure you're getting your 3 marks for it there, okay? So linking reaction time, don't say it slows down, say it's a longer reaction time, meaning the thinking distance goes up. Okay, right, next question, we're going to move on to waves here. Okay, this is a higher tier only question, but it's about refraction. Okay, now most refraction-based questions recently, just as a note, they ask you to explain it, they give you the wave fronts. Okay, so wave fronts are these lines here, these represent a peak of a wave, and they don't ask you to talk about density or what happens inside the block. All they ask you to do is explain in terms of wave fronts why refraction happens. And the mark seems to be the same for every year this has come up. What you have to say is about which side of the wavefront hits the glass first. So the first side that hits it first is kind of the right-hand side of the wavefront, or the bottom from the way we're looking at it. But you have to, in your answer, show that different parts of the wavefront enter the glass at different times, and then they slow down. So you do get marked for saying that light slows down in glass, but you'd say that the one on the right or the bottom part changes speed before the top part. Okay, learn that. 3 marks, should be easy peasy. Longitudinal and transverse should be something you learn word perfectly as well. You can't really blag this definition, you have to learn it. So a question like this would say, describe the differences between longitudinal and transverse waves. Could be 3 marks, sometimes it's 2 marks as well. So you need to know that oscillation or vibration causing the wave is perpendicular to the direction of energy transfer, and for longitudinal wave is parallel to the direction of energy transfer. Okay, learn it word perfectly. Don't try and fudge it. Don't try and draw diagrams unless it asks you to. That's the full definition for this question. This next question is higher tier only. It talks about radio waves being part of the electromagnetic spectrum, and the question says, explain how electrical signals in the transmitter produce a signal in the receiver. So it's an explain question. It's quite a tricky one. It does come up relatively often, combined science or separate science, and the idea is this. So radio waves come from the transmitter. We talk about how they're produced and then how they're received. Okay, so first thing to notice is that if you were to kind of sketch it on, you could see radio waves going from one thing to another. Now, it's not magic, and I'll tell you how they are produced. So the idea is that inside the transmitter, so where they're produced, there are electrons. It's metal, and the way the radio waves are produced is by an electric current. Now, electric current has to be oscillating, or essentially alternating current, up and down, and that's what produces radio waves. Now, I know that doesn't make much sense. You'd have to do A-level physics to really understand that, but that's how they're produced. Now, they then travel through the air, they get to the receiver, and the receiver absorbs the radio waves, and that then induces electrical current or electrical oscillations inside the receiver. Now, the receiver has electrons in it because it's metal, like air on top of a house, and that's how it's received. Now, the last mark for a question like this would be, well, to receive a radio signal, it has to be the same frequency as what it's transmitted by. Otherwise, you'd be hearing something or seeing something through TV would be different to what the transmitter transmits it at. So another good one to memorize word perfectly there. Okay, now for the last two, you're going to talk about magnets and magnetic fields. Now this one is on combined science and separate science, and it will come up in any form. This is an example of a lock that works by an electromagnet. So any lock, for example, on your school gate that needs electricity to work would work in this way. So we've got a solenoid, which is just a coil of wire. We've got a bolt, we've got a door and a spring, and an electrical circuit. So the question is, explain why the door unlocks when the switch is closed. Now the first mark is the easiest mark you should be able to get on this paper. The first mark is just to say, well, when the switch is closed, there's a current flowing in the circuit. Easy peasy. Now, why does that matter? Well, if there's current flowing in a solenoid or in a coil of wire, it creates a magnetic field around it. So this solenoid is basically a magnet, similar to an electromagnet, just without the iron bar in the middle. So with the magnetic field, what it does is it attracts the bolt. Now, as it attracts the bolt, the whole door opens. But you don't even need to mention that from this mark scheme. You just need to mention those three things. Now, the context this could come up in, it could be like an electric bell, it could be a circuit breaker, anything like that. It's basically the same mark scheme. It's becoming a magnet or magnetic field because there's current flowing, and then you've got to figure out what happens in the context of the question you're given. Right, the next 3 or 4 I'm going to look at are either higher tier or separate science only, and I'm going to just say it to you now, it'll be one of the last questions on paper 2, and it's really important you know how to answer these word perfectly. Go watch my videos if you want a bit more explanation. So here's your first one. Now this is an example of the motor effect, and the question just down the bottom left here says, explain why coil rotates when there's a current in the coil. So what we say, and for motor effect, here's the general gist. This doesn't get you new marks, but just so you understand what happens in the motor effect, is that when you have current flowing in a magnetic field, something will move. That's essentially what's happening with the motor effect here. Okay, so how we say it is like this. So we say there is a magnetic field present between the north and south. That should be an easy mark to be able to see. Now, as well as that, there's also a current in the wire which causes a magnetic field. So throughout this wire here, because there's a current flowing, just like in the last question, because it's a coil of wire, there's a magnetic field. And some mark schemes would say the two magnetic fields interact. So I'll put that in brackets here. It's a good thing to learn. Now the current, the reason it rotates is because the current is in opposite direction. If you watch the current going round from the circuit here, through the coil, up the left and down the right, it is in opposite directions on each side of the coil. So therefore the force that acts on each side will go up in one direction and down in another direction, meaning that it is going to rotate overall. Okay, now the last thing is to talk about the split ring commutator. Okay, now the split ring commutator, you can say it in a couple of different ways. I'll put both ways down from the mark scheme here. It says that it allows the force on the left and the right side of the coil to make the coil flow in the same direction, to rotate in the same direction. You could just say what the commutator does, which is, this is the thing I'd probably memorize, is that the current reverses every half rotation. Okay, so any question about a motor, why it rotates, that is your mark scheme to use. Obviously, you're looking at the diagram carefully. Right, next one. This is an application of the motor effect. This one is separate physics only, but look how similar this is to the last question about the motor effect. So this talks about a moving coil loudspeaker, basically just a loudspeaker. Essentially, how does it work? How does it produce a sound wave? So the explanation is very similar for a motor effect. We need to talk about the current, we need to talk about the magnetic field, and describe motion. Okay, so the idea is the current through the coil creates a magnetic field. And there's a permanent magnetic field as well. You can see S and N, south and north, from the permanent magnet. That's 2 marks already. Now, what then happens is there is a resultant force that causes the coil to move, okay? But not just move. It doesn't just go up or down. It vibrates. It goes up and down. So the idea is the AC supply, the current, makes the current go back and forth, change directions. So therefore, the direction of the current reverses, so the direction of the force reverses. And I would say even here, I've seen other mark schemes say you've got to talk about the cone then vibrating. That causes the air particle to vibrate at the same frequency. And that's what a sound wave is. Sound is just air particles vibrating back and forth. So that's your perfect answer for a loudspeaker. Okay, separate physics only again this time. We're going to talk about generators. So it looks very similar to a motor, this does, but you should be able to notice this time there's no power supply, there's no battery, there's just a lamp, or it could be an ammeter or a voltmeter, something like that. So the key parts of the generator effect are that, unlike the motor effect, it tells you the coil is rotated and we get current induced. So it's kind of the opposite. So again, you don't get marks for this one, but I always think of it like this. So you have motion going in into a conductor in a magnetic field, you get current or PD induced out of it, basically. Okay, and it is a dynamo, which we'll come on to what that means in a second. But for any question to do with the generators or generator effect, this mark scheme is ideal to learn and memorize. So the idea is the coil moves through the magnetic field. It could be the magnetic field moves in a coil, but in this case it's a coil going round and round a magnetic field. There is a PD, a potential difference, induced. And therefore, because it's a complete circuit, because we've got a bulb and the circuit, two sides are connected, there is going to be a current induced. That 3 marks will be the same regardless. Because it's a dynamo, we do need to talk about why there's a direct current. So it begins with D, dynamo means direct current is induced. And that is due to this thing called the commutator, which is very similar to what happens in the motor effect. It does the same thing, but kind of in reverse. So every half revolution, the commutator switches brushes. And the effect is not that it keeps the thing turning, but it keeps the current in the same direction. So we'd say the direction of the current doesn't change or doesn't reverse every half rotation. So it doesn't go positive, negative, it just stays in the same direction. Now, this is applied in a microphone, which is an example of the generator effect. Now, I've just put the mark scheme up here just to see how similar this is to the generator effect. So sound waves this time are what causes the motion initially, rather than someone turning a coil. But the idea is a diaphragm from this diagram, you could say a cone if it talks about a cone, causes the coil or the wire to vibrate, to go up and down. Coil moves through magnetic field, cuts the magnetic field lines, PD is induced. Okay, look at the words that are underlined each time. It's always induced. It's always a PD that then causes there to be a current induced and go elsewhere in the circuit. Okay, so this will be one of the last questions on your paper, almost always is magnetic fields. And if you're separate science, you need to make sure you know these. Could be 4 marks, could be 5 marks, could even be a 6 marker coming up on your paper too. So I hope you found this helpful. And like I said, make sure you revise them properly, word perfectly. So if they come up, you are going to be answering them easy peasy.